All right, everyone, this is the assignment that we're going to be doing for today's lab. This is actually the motorcycle uh, strobe light mount that I made for my motorcycle. Um, it looks pretty complicated here, but remember everything in blue here is not required for the assignment. Um, I figured that these holes just added a lot of unnecessary time to the assignment. Um, but now I'm going to start a part and we're going to do it here together. So just click part, OK, and start in your front plane, start a new sketch. And what I'm going to do is look at back at this guy. We're going to start making this profile first because it has the most information about the part and we can get the most done in a single sketch. We have this weird curve here. We have the two main circular arcs here, the 58 and the 50 millimeter diameters. Also note this is all in millimeters, so you're going to have to change your units. You'll likely have to change your units in your assignment in SolidWorks down here at the bottom right to millimeters instead of inch pound second. So go ahead and do that. So we'll go back to our new part and we're going to start in that front view. So what I'm going to start by doing is just two circles here. I'm going to make the first one 50 millimeters and the second one 58. And you can see these leader lines aren't bent the way I like them to be. If that's the case, it's probably something is going on in document properties. It says ANSI, but I'm just going to switch it to ISO and then switch it back to ANSI. And now they're bent leaders, but you also see there's way too many zeros. So we go back to document properties and then go down to dimensions here. We can change this to 2 decimal places instead of 4. And now we have it the way we want it. So now I'm going to add that rectangle at the bottom and add this straight up. And one way I can get this to be centered very easily is to just select the midpoint on here. You can also hover over the line to select the midpoint and make these vertical. And then we can see another dimension that we have here on the drawing is 23.5. And this dimension here is 98 millimeters. Now we can add the little section for the bolts here. What I'm going to start with is making an arc around the center for the central cutout and adding a line across and adding another line across. A quick tip, if you want to switch between having the line tool and not having the line tool, pressing L on your keyboard activates the line tool. And then if you don't want it to automatically add another line, you just press escape and then I can click L and have a line again. So that's another tip there. So now we want this distance here to be 6 millimeters. And notice this guy did not get a tangent relation, so I'm just going to select both of these and make these guys tangent. Bring these out a little bit. And now I'm going to add another arc here. That goes like so. And you can see if it's going the wrong way when you first place it down, you can just bring your mouse back and come back out, and it changes the arc to be going the way that you want it to go. Now I am going to attach these lines to this arc and bring a line from each of these to the central arc. And tangent, tangent. And now, because there's a cutout in the middle, I'm going to use the trim tool here to cut the center out. And these are both still co-radial here and concentric. I'm going to make them horizontal. Now I'm going to make this line and this curve also tangent, and this line and this curve, the same curve, tangent. This is important for the getting the volume right and making your sketch fully defined. If you don't make those tangent and you use some other definition to make it fully defined, your sketch, your first sketch will be off, and your first extrude will be the wrong volume. Also notice here this very short segment of the curve here that is between this line and this line. These two lines are not actually connected. So let's continue. We see in our drawing, our initial drawing, if we look at it, that outer curve does not continue down, so we don't need that outer curve. So I can go to my sketch, select trim entities, and trim this guy and this guy off. And then I can also trim both of these inner lines. And now I'm getting pretty close to what I need. I have another dimension here from my drawing that is this dimension. This should be, I think it's 15. Let's look at it. Yeah, that's 15. And then the radius for both of these guys is 16. And now our sketch is fully defined. I do need to cut this guy off as well. And now you can see I have multiple contours here. So if I just try to extrude this and go over to features, it's not gonna show me any preview, and it's automatically gonna have this selected contours drop down open down here because it's not sure, do I want this contour or this contour selected? But I'm doing that on purpose because if you look at the part, you see that there's a back wall here that is this whole profile. And we can do that back wall first and then do the outer profile for the rest of the part without having to make another sketch. So I'm going to select this profile and this profile at the beginning and do 5 millimeters and then select OK. And now I have this part. And if you click this little drop down caret here, you can see that the picture for the sketch, the little sprite here, is not the typical sketch shape. If I open a sketch here, this is the sketch icon. The reason it's different is because this is showing that I'm not extruding the entire sketch. I'm only extruding certain selected contours. So now I'm going to go back and select the sketch, go to features, do an extrude again, and then only select the outer contour and extrude 60 millimeters. I believe that's what we have here. If I hover over, yes, 60 millimeters. And now you can see we have another add on to our little sprite here, which is that little hand holding the sketch. Um, that little hand means that that sketch is being used by more than one feature. It's being used by Boss Extrude 1 and Boss Extrude 2. Also, in previous assignments, you guys had to rename these. You don't have to rename them for this assignment because we're not requiring you to upload a screenshot. So that's the second step. You can see that we extruded this whole side here. If we look at the part, this whole side, it doesn't really look like this at all yet, but we're just going to have to cut material and remove material to get this shape. So now if I go back, the next thing that we can do is cut out that circle in the bottom. And if you notice, that circle is not actually just a cylindrical cut. You can see the radius here on this side is 50.5 and the radius here is 46.5. The part that mates with this, the headlight, is actually cone shaped, and so this cut has to be cone shaped to fit with that light. So there's a couple ways we can do this. We can make a circle here like so, and then do an extruded cut. And then instead of straight, we can select this option here, which is a draft. And you can see this is getting smaller. I actually want it to get larger. And it's somewhere around 4 degrees, but it's not an even number. It's a trailing decimal, a really long decimal. And this just isn't a very good way to do it if you have the 2 dimensions. So instead of doing that, we're going to use the 2 end dimensions, discard this sketch, and we are going to do a revolved cut instead. So I'm going to go normal to this plane. One way you can do it is going normal to, or clicking the plane and pressing Control 8. And I'm going to select the plane and start a new sketch. And now I'm going to make an outline of the revolve that I want. Now, actually, before I do that, notice in the part here, I forgot to add these 2 fillets that are on the corner. I'm going to add those first. I didn't add them in the sketch because it makes that little segment, that little short segment here, disappear, and it kind of messes up the dimensions. So it's much easier to add the fillet after extruding the full part. I frequently like to do that because adding the fillet just as a feature greatly simplifies the sketches that you have to do rather than adding the fillet within the sketch. So before I do that, I'm going to roll back here and add my 2 fillets here and here. And what is the dimension on these guys? 10 millimeters. Okay, so we got 10 millimeters. Okay, now I can roll back down, and you can see my sketch is below the fillet, even though I made the sketch before I made the fillet, because I used this rollback bar. So now we're going to go back to this sketch, Control 8 to go normal to the sketch. And I'm going to add 2 center lines in just random spots here. And these center lines, I'm going to make the dimension from the half of the radius of each circle on either side, because this is a revolved cut. And this will be 46.5 over 2. And this will be 50.5 over 2. And now we have a nice curve. And then I'm going to make this dimension here the same 23.5. And you might be wondering, why didn't I just put these center lines on the outside of the part? Well, the reason is if I change the width of this side of this edge here, then that will move these center lines and that will change the draft angle or the taper angle of this revolved cut. And I want it to stay the same even if I update the design later. And the only way to do that is to have these center lines independent of these two edges here. So we still need it to be centered though. So what I can do is I can add a center line here and go across like so. Don't make it at an angle to the other one, make it straight across. And then select the midpoint, hover over, and then select the origin and go vertical like so. And these are still not attached to these edges. And I can show you that in a minute. But now we need the distance from the central axis. We can see in the part here in blue, or in right above the part in blue, it says axes are perpendicular and the distance between axes is 55. So 55 millimeters. This is going to be the central axis of it. So I'm going to make this 55. And you can see why I'm extending this line out, because those fillets from earlier need to be cut. If I just went up to this face here, or if I use an extruded cut, it would not necessarily cut these fillets here unless I somehow told it to extend the draft out from the part. So now that leaves us with determining where we should drag these. We don't want to bring them all the way in because they won't cut this fillet if we do that. But what if I, again, like I said before, what if I change this dimension of this part here and it goes out beyond this? Then it might break the way that this cut is working. So what I can do is I can just add some arbitrary dimensions here, maybe 10 millimeters on this side, and 10 millimeters on this side, like so. And I could make these 10 millimeters just from the edge, like so, and then it'll always be 10 millimeters away from the edge. But another thing that you can do that is really nice in SolidWorks is you can use relations between your dimensions, not just between your lines. And the way to do that is to go up to Tools, and then come all the way down and go to Equations. And you'll see all this stuff here. And I am going to go to, you can see we have global equations here, we have sketch equations, and then we want to see our dimensions. Now, this is a whole list of dimensions from all my different sketches in the part. You can see my dimensions in sketch 1 and my dimensions in sketch 4. This is really just sketch 2, but I created and deleted a couple sketches, so it renamed it to sketch 4. You can see the two 10 millimeter dimensions that I just added, but something I can do is I can delete this and add an equal sign and then click this previous dimension, D5, sketch 4, and click OK. And now you can see this little equation sign here. And if I change this dimension to say 15 millimeters, this guy will follow that. And now an even better thing that I can do now is go over to my equations again, and I can make this guy D5 equal to something like that original dimension that I had that I'm thinking about maybe changing over, let's say, over 3. Hit OK. And now it's dividing that dimension by 3. So now whenever I change that dimension, it will extend that sketch. So I'll just show you that now. An easy way to change dimensions without searching for the sketch in the feature tree is to just double click your part. Sometimes it's just a single click, sometimes you have to double click it and then double click your dimension. Let's say change this to 30 and I can edit my sketch here. And you can see that these dimensions changed in response to that dimension changing. So there's a lot of cool stuff you can do in SolidWorks with your different equations. Another interesting thing is when you're in a sketch, you can make an equation-driven curve, not just a spline. That's under the spline tool. So if I edit this sketch, Control 8 to go normal, I can go to equation-driven curve and make it y equals 5 times sine x and give my range. So I'm going to go 0 to, let's say, 10. And it says my equation is invalid. Let's see, explicit. I think I need parentheses here. Let's try this. There we go. And you can see I have a sine x. So there's a lot of cool things with equations you can do in SolidWorks, but we don't need that now. Now we have this sketch that we need. We're going to go to features and do revolved cut. Now it's going to ask us what our axis of revolution is. It's going to be the central axis here. And you can see there's a problem here. It's not in the middle. But this is actually a very easy problem to fix. We don't need to redo the sketch. We can just click the green check mark here and then use this rollback bar again and roll back before we did that sketch and that cut. And we can do our reference plane because we need to have a plane in the middle, right? We need this sketch to be applied in the middle of the part. So I'm going to click reference plane and then just simply click the two sides and it'll automatically recognize that if I have two parallel planes selected, I want my reference plane to be halfway between the two. So it'll go to mid plane here. So I'm going to click OK and then bring this bar back down, click this caret, and now you can either right click or left click on a sketch, and instead of edit sketch, you have this option edit sketch plane here, and you can click edit sketch plane, and now you can either rotate around and click the plane here, or whenever you have some feature that you're modifying, you'll have your feature tree over here instead of here because this space is being taken up by the modification that you're doing. And you can click the little drop down and click the plane here. And then click OK. And now my cut is in the middle and I can hide this plane because I don't need this plane anymore. And now we're almost there. So now we have this circular cutout. This cut, it's starting to look a lot more like what we need. So let's look at our sketch here, our assignment, and see what else we need. Now we need this each corner cut off like so. And we see we have a radius here of 5 millimeters and some curve here. And then we have a couple dimensions, 7.9 and 7 here for the gap. So let's add that in now. So I'm going to go normal 2, sketch, and I'm going to add a rectangle here for the central cutout. I'm going to make this guy 7 millimeters. That's the width of the gap. And then I'm going to select the midpoint of this guy and make them vertical so that my central cutout is there. And then instead of cutting this, I'm also going to make the other part of the cut and do it all at once. So let's go from here over and then up to here. and then add an arc that comes down, and another vertical line, vertical, and then add a fillet here that's 5 millimeters. And now I'm going to make this curve. This is important. Oh, undo this fillet. This curve and this line tangent. And that will bring this guy. I want this guy to be concentric with the central circle. So select both of those, make them concentric. And now we're almost done with this first half. This is 7.9. And now all we have to do is mirror that to the other side. So I'm going to add a center line here as my mirror axis. And then I can just click in the middle of a contour, enclosed contour, to select everything. And then I can click mirror entities, mirror about, check. And now you can see we only have 3 dimensions that we really need for this. So 5, 7.9, and 7. And now I can go to features, do extruded cut. I'm going to do up to next instead of having to make it go all the way through like that. And then select it. And then we're almost done. There are holes up here in the part. Those are just extra credit. You can figure those out on your own or ask me during lab. And then the holes on the side are also extra credit. But we do need the holes down here. This is, as you can see, something that clamps around something else. And same with this clamps down. That's what this cutout is for. So I am going to go normal 2 here on this side. This side is where our tapped hole is. So I'm going to go to Hole Wizard and select tapped hole here. And it already has the size specified because I've already made this hole. But let's say you were in something else and you're in like some standard countersink. So you would click tapped hole, make sure you're in ANSI metric instead of ANSI inch, and then go to just regular tapped hole. Click the drop down here, and then it is M5 by 0.8. And make sure up to next is selected. Now go to positions, and it asks for a 2D sketch. We can just click on this face here and add our threaded hole. Now you can see if I have up to next selected, it only goes through this side. But if I go to through all, it will add the thread to both sides. We don't want that. We just want it on this side. So up to next. And now we need to define where it is. Control 8 to go normal 2. Now it's in the middle, so we can just make it vertical with the origin. And then it is 6 millimeters from the bottom. Now we can hit OK. And now we have our threads coming through. And just be sure you don't have a countersink on here. It might accidentally add a countersink or default to adding a countersink at the bottom. Where it'd say near side countersink would be checked. We don't want that because the bolt is just coming through here and then threading into this side. Now I can go normal to this side and add a separate hole. Use Hole Wizard again. Go to Legacy hole because we're adding a counterbore. We're not going to use the standard counterbores that SolidWorks has embedded in it, we're going to instead dimension the counterbore ourselves. So click the drop down, click counterbore, scroll down, and this counterbore has a through hole of 5 millimeters and a depth of going all the way through or up to next. Make sure it's up to next, not through all, because that will cut out the threads on the other side. And then the counterbore diameter is 9 millimeters. And the depth is 4.9. Now we can go to positions, place this guy down. Same thing as the other side. Oops. Vertical with the origin. And if I press Control 8 again, it will flip me to the other side of the part. And I can just drag this, click Control, click the threads, and go concentric. And I don't even have to add that 6 millimeter dimension. It'll just be tied to where the threads are. So if I change the location of the threads, the counterbore will change with it. So I can click OK. And now I'm done with my part. And you can click Evaluate, Mass Properties, and find out what your volume is. Okay, now that you guys have your part fully made, if your volume is off, I do want to note to you guys that when I was editing the part and showing you guys, I changed this 23.5 to 30 millimeters. The correct distance here is 23.5. So if your volume is too large, make sure your volume here is, or your dimension here is 23.5. But now I want to show you guys some tips for the drawing that you guys will make. And I also want to show you how to make a add your geometric tolerances to your part. So for this part, you only need 2 views if you're making if you're not doing the extra credit. If you're doing the extra credit, you need a top view to dimension the vertical holes in the part. So let's go over to drawing, go over to model view, and then select our light mount and add it in here. You can see this is the drawing that, or the part that I made that is completely defined. It has the extra credit holes in it as well. So don't worry about that if you don't have those. I'm just going to click OK and delete the note that it started out with and delete these center marks because we want them on a different layer. And it adds 2 on top of each other because there's another hole behind it. Now this is a little small, so I recommend making the scale 1:1. And then this is the front view. What we actually need is another projected view here. You can do projected view if you want to add views back again. Again, that's selecting the view and then doing projected view. And we want the left side view actually, not the right side view, because the left side we can dimension both of these curves here. The right side view, you can't see both curves. The larger one in that view is actually a hidden line. So make sure you have your hidden lines turned on. So go up here, go to hidden lines, turn those on. Also turn off your tangent edges. There's a whole list of things in the original assignment that you need to do that you guys have been doing for all your labs. So make sure you've done all of those. And then we can start dimensioning. We can start adding our center marks and center lines. one thing that we can do is change the layers as well. Now, notice this depth here. You cannot just dimension that with Smart Dimension because you're dimensioning to a hidden line. So you guys will need a broken out section for that in this corner. If I go to broken out section in my drawing tab here, broken out section, and I draw a spline around here, notice it either asks you to click something in here for a depth or to click, or you can just set the dimension here. I think it's better to just set the dimension because there's not really any edge here you can select. I believe it's 30 millimeters. Yes, 30 works, and then you're right in the middle of the part, or pretty close to the middle of the part since it's 58/2, um, not 60/2. And now you're in the middle and you can dimension this line. Now, another thing you guys can do is when you're doing your dimensions here on a new layer, is notice that it adds a radius instead of a diameter. You can just click the number here to change it to diameter, and you can go to liters and change how it's displayed like so, and then it's just pointing to it. Now another thing is it doesn't have bent liters, so again we need to go to options, document properties, change it to ISO, click OK, and then change it back to ANSI and change our dimensions here back to 2, click OK, and now we have our bent liters back. Now you can do that for a lot of your curves here. You can do that for these curves as well. Displaying this as a diameter is just a lot nicer. You can also do that here because this really is, it's just easier to display these larger holes as diameters. Now, another thing that you guys should note here is this little nose here, these two curves here. You'll need to add, this is left over from before, I'm going to hide that. You'll need to add the radius dimension for these guys, for both of them, and you can put 2x. You guys are going to have a lot of 2x dimensions in this part, so just be aware of that, and that'll apply to both of these. But the machinist doesn't know that these follow the same curve, so it's best to go to center mark and not only add a center mark for this guy, but make sure you're on linear center marks. Also add a center mark for these guys, just so the machinist knows, and this will be on a new layer, of course, not on the same layer as the part, but this tells the machinist that these two curves are concentric, and you can even add a dimension between these two center marks and put them in parentheses. Put the dimension in parentheses as a reference because you don't actually need this dimension to fully define the part, because what we care about is this 15 millimeters that was shown in the drawing. But this just helps the machinist know what's going on with these curves, that they're both centered here and that they're this far away from the center. That essentially tells them that this curve and this line are tangent, and this curve and the line are tangent here. Now, another thing that will tell you guys is these holes here. How can you dimension these properly or do a call out for this counterbore and this threads? When we don't like to do them, to do our call outs in side views like this, but they're laid on top of each other in this view. A nice way you can do that is you can use hole callout and modify the hole callout, or you can use smart dimension and modify the smart dimension. And click on the outside for the counter bore, and click on one of these inner lines for the threads, and modify these guys to say you can get rid of the 6H, and you can say near side for the threads and far side for the counter bore, because we're looking to the left into this view, so the threads are the ones that are facing us, and that adds extra clarity for the machinist. And you can get rid of the drill diameter as well for this thread here. And you don't need through on any of them. We never include through, so we can just delete that. M5 by 0.8 near side. Now, the other things that you guys will need for this, completing this drawing, is again, when you have your central axis here, say for your center mark for these guys, be sure to measure where that center mark is from the side, because the machinist doesn't know that it's in the center. You have to tell them that it's in the center. And then you can add this dimension either from the center mark or from the side. Either way is okay. I'm going to do it from the side. And then I'm going to chain dimension this gap here, because that's an important dimension, the spacing that you're going to have to clamp this thing down. And then you'll have the width of this guy as well. You could also baseline dimension that. Now, now for adding your geometric tolerances, let's see, there's a couple of things that we have here. We have that this side here is our datum A, and that's what we need to add as a datum. So I can add a dimension here first, just to add the width of this part, 60 millimeters. And I can add a geometric tolerance. This is both our datum and our geometric, and has a geometric tolerance. And we will be referring to that datum for other geometric tolerances in this part. For example, one of our surfaces, this flat surface here, is said to be perpendicular to this surface here. So I'm going to add a geometric tolerance to this side here. And according to the assignment, it says it's flat to 0.01. This is the flatness symbol. If you forget, you can always hover over and it'll tell you. This is the flatness symbol, and it needs to be 0.01 millimeters. So that's okay. And if you remember from lecture, flatness does not need a reference to another datum. It's just a geometric tolerance by itself. So we don't need to do add datum. In fact, add datum is grayed out because it knows that flatness does not need a reference. So we're going to do done, okay. And what we can do instead of having an arrow, because an arrow is rather confusing if you have a lot of lines close to each other, is you can click no leader, click OK, and sometimes it kind of gets stuck, so you can drag it back on to the line like so, or sometimes, there we go, you can drag it back onto a leader line that we had. Trying to flip the side, there we go, and it can hitch a ride on a leader line like so. And if you want it outside of the leader line, you can click the dimension and then drag this little arrow up to it, and now it has its own little leader line. And now we also need to specify this surface as a datum, as our datum A. So I can click on datum feature here, A, and I can either click on the edge or click on, looks like it automatically added it. Let's click that again. Or we can add it to the geometric control frame here, and it can hitch a ride on that control frame. And this is the preferred way of doing it so that we don't have geometric tolerances all over the place. Now, for this assignment, I want you guys to change the layer of all of your geometric tolerances. So I'm going to make a new layer. New. I'm just going to name it GD&T. And I'll change it to green. Okay. And then I'm going to click this and change it to GD&T. Click this guy, change it to GD&T. I want all your geometric tolerances to be on a different layer. Okay, now the next datum that we have a couple. We have this one here. It's supposed to be parallel to A. This is supposed to be a surface. It's not a datum itself, but it is just parallel to datum A to 0.025. So I'm going to add a geometric tolerance there. And I'm going to hit parallel. And then I'm going to add a datum to this feature control frame. But before we do that, we need to change this to 0.025. And then to add a datum to the feature control frame, you just click Add Datum. And it's automatically defaults to A because you're usually not going to have that many datums. If I wanted to add another datum to this box, let's say it was perpendicular, and I had another datum down here that was flat, and I wanted it perpendicular to that datum, and then perpendicular to this side, I could add another datum in here. But this is all we need for this guy, so I'm just going to do done, no leader, okay, and then just drag it to the leader line and attach the leader line and bring this guy down. Now we have a couple more. We have cylindricity for this cylindrical cut. I'll leave that up to you guys to figure out. But for this bottom edge, this is supposed to be perpendicular to A, so I'm going to add a geometric tolerance here. And before I do that, I'm actually going to add the height here so we have a leader line. Annotation, smart dimension. Sometimes center marks can be weird. 98 millimeters. And add this width as well. 23.5. And then add my geometric tolerance saying that this bottom surface is perpendicular to datum A to 0.02. Datum A, done. No leaders. Click the check. Don't forget to click the check mark. Then drag it to here, just like all the other ones. And now this also needs to be datum B. So I'm going to add a datum feature and attach it to the feature control frame. It says C because I was playing around, but I'm going to make it B. And you can change it afterwards by clicking the check mark here. And so this is saying that this surface here is datum B, but that it is perpendicular to datum A. So the letter in the feature control frame is what you're referencing, and the one that is on this datum feature is the datum that is this bottom surface here. Now we have one more besides the cylindrical geometric tolerance, which is these two surfaces need to be parallel to B. So I can click this guy, and instead of adding it twice, I can click here, hold Control while it is before I have placed it down, and then hold Control, and then click on an edge, and now I have two leader arrows. I can click here, click parallel, and then make this guy parallel to B to 0.025, add datum, B, done. And now these two surfaces are parallel. I'm not going to get rid of the leader lines, I'm just going to keep them so that I can reference both of these. Now you guys should be pretty much done. You have some dimensions to add. Don't forget the dimension here. And feel free to ask me or the TAs for any questions you might have.